Testing, testing. 1, 2, 3. Oh, create a poll. There's a new stuff. Cool. Are you? Yes or no? Oh, oh man, I have to end that and redo it in the form more befitting a person who likes the game Earthbound. It's like, what town are you from? Yes or no? Oh, got it. Good morning. Ha! I like this. Oh, I like that a lot. Ha! I noticed this morning when when I was setting up the streams that they've changed things on me. I now need like to click through 3 different screens to you know, set up the stream the way that I want it. They don't have all the options on one page anymore, and you know, that takes slightly longer. But if they added polling, man, and it seems to have a pretty good response, like a pretty good feedback rate as well. I like that. Yeah, that could be like a cool teaching tool, as it were. Yeah, very cool, very awesome. All right, well, might as well get started then. Good morning, fancy meat computers. Welcome to this, our penultimate week of classes. Just a quick reminder for those of you who are out of jurisdiction. Next Monday is the civic holiday Monday in Canada, so we are not going to have class. It's a federal holiday, so everybody gets the day off, except if you work like for a company that says you don't. But most people will get the day off. Large exceptions being people who work like retail and in restaurants and that sort of thing. You know, the restaurant business pretty booming on any holiday. So, at any rate, we will not have classes. We will have classes on Tuesday. And Tuesday will be our last class. Hooray! Congratulations, folks. You have persevered. You have... Could you do a poll to see if we understand the stuff? Yeah, that's not a bad idea, actually. We're almost through the course. We're very close. Yeah, it's going to be awesome. The exam is coming up next week, at the end of next week. So what I'm going to do for the final class, it's going to be a little bit lighter on the lecturing material, like the direct lecture material, and we're going to use about, hopefully, half that class as an exam review session. So if you have any questions pertaining to the course, pertaining to this, pertaining to that, please, please, please prepare those questions for Tuesday next week, and we'll go through them. Further to that, I'm giving you guys an extra day to do the labs and the assignment 2 relative to the way that we usually make things do. So that will be the due date for those is Tuesday at 10:30 rather than Monday at 10:30 because Monday is a holiday. So, yep, that's all true. Could we do a poll to see if you understand stuff? Okay, I'm going to end that poll. I'm going to do a new poll. New poll. Poll. Can you change your answers as you go, or is it like one vote, one, like, if you vote once, that's it? That would be interesting to know. If you could change your... Because if you can change your polling opinion, then, you know... That would be interesting to know. Yes. And no. Yes, no. And very. Bonk. One vote? You only get to vote once? Okay. Might have to refresh that every once in a while then. That's cool. It's like, you know, give a, I like this. I really like this. So, anyway. Yeah. Well, if you vote no, then, are you... Come on. We haven't even started yet. I suppose I get what I deserve, eh? Okay. So, we should get on with it. Get on with it! So, anyway. So we're going to talk about a pretty expansive range of topics today. It's going to be focusing primarily on what are called the Glob patterns and regular expressions. Those are sort of your big takeaways today. We're also going to talk a bit about documentation. Documentation is going to be covered quite extensively in the lab that you have going on today, Lab 9. So we're going to sort of introduce some concepts, and those concepts are going to be much more fully explored in the lab session itself. So, yeah. That's good. That's good. If you don't know what these terms mean, don't worry, you will. But, yeah. So, let's just get started. So, stream redirection. We have been playing around with stream redirection in a number of ways over the course of the course so far. You'll have seen this a couple of times in... you'll have seen this a couple of times in the lab where I ask you to redirect the output that gets output to standard output and dump it into a file, right? That is a type of stream redirection, but there are obviously more types than just that. So the one that you're going to find is very, very useful for Lab 10. Lab 10, incidentally, is going to be published this afternoon, so you can take a look at it if you want. But this is generally speaking, this is called the pipe because, well, technically it's vertical bar character, but we call it pipe because it pipes X's standard output to Y's standard input. So, in Unix, we write programs to handle text streams because of the universality of interface. Essentially, pretty much everything in Unix is designed to take a interface of one type or another from specifically... Sorry, let me rephrase that. It's designed to take data of one form or another from standard input or standard output, or from standard input specifically, and to output it to standard output. That's why they call them standard input and output. So we think of standard input, standard output, and standard error as being streams of data, right? They're buffers. They contain data until something empties them. The thing that empties them could be your terminal, but it could also be a file if you direct the things that were going to be put into the terminal's output into a file. That's how pipes work. So I don't think it's technically correct, but I kind of refer to all of these different types of operations as pipes. So if these are streams, right, you direct a stream using a pipe. Pipes. So that's a good way to think about these things. So, this one you'll know. This is standard output gets written to file Y. This is one you'll probably have seen less commonly, although it was in the lab on testing, I believe. File Y is redirected to X's standard input. And of course, you know, writing C programs, using printf and scanf, these are things that interact with standard output and standard input. So if you want to write a C program that interacts with things being fed into it using these pipes, all you have to do is design it to use standard input and standard output using printf and scanf, which you should be fairly familiar with at this point. So, incidentally, if you do have, if you are lost, it helps to have a specific question. So I think this is in addition to the regular chat, not a replacement for it. So, and of course, we have similar ones for standard error and to write both standard error and standard output. But this is the guy that we're going to be using mostly today. So if you have two commands, right, Command X and Command Y, it is possible to redirect the output of one command as the input of another. This is what the pipe character does. And we're going to see various examples of this today. So, we've used redirection to and from files a number of times in labs already. So let's take a look at pipe vertical bar. So here are some examples. Redirect long output so that it can be made easier to scroll through. So, for example, let me just get into my folder. 1XC3. Make dear topic 9. Sure. Oh, you know what has a very long, what a really long file is LaTeX log files, for whatever reason. LaTeX is the document preparation system and typesetting system that I use for all of my labs and all of the slides and such. So, topic 11, there we go. So if I were to just cat topic, or topic 11.log, you can see it's like all this. Look at all this. There's so much to look at. However, if I take the output, pipe it into more, then I get a way of viewing it. Viewing it? Maybe less. Less uses arrow keys, and that's more useful. And I know that you can do this just directly by typing less. But the difference here is that less is taking all of this information from standard output instead of reading the file directly. So notice, we don't have to specify the file name, right? We're not specifying a file name. Less is getting its input from our cat operation, which dumps the contents of topic 11 into standard output. So there you go. Incidentally, you guys, I don't know if you guys answered this. Can you, I've never used this voting system before. Can you change your vote? Like, you do get one vote, but can you change it mid-poll? Because if you can't, then this is pretty useless in the way that I'm using it currently. This seems to have less latency than the chat. No, you can't change your vote. Okay. Actually, whoa. Okay. That was really fast. Maybe YouTube also, reduced the chat latency considerably. So I'm going to... Okay. When I give the signal, if somebody could just, print, just type yes into, or not yes, the word cookie. When I clap my hands, if you could type the word cookie into the chat and then press enter, I want to see what the latency is. Okay? $10 seconds. That's good. Normally it's around half a minute. Wow, I'm impressed, YouTube. I'm impressed. Okay. I'm gonna end this poll though. If you can't change your answers, then it doesn't really... Okay, Dahlia is 10 seconds. The rest of you are 15 seconds. But that's significant. That's a significant improvement. Anyway. So here's another example. Let's say we wanted to retrieve the third line of a file. And here are some commands that we've never seen before, head and tail. So, if you call head on head-3 on topic 11.log, it gives you the first 3 lines of a file. If you type tail 3, that gives you, oh, it's expecting input, topic 11.log, then this will be the last 3 lines. Like if I cat topic 11.log, those are the last 3 lines, right? So, so head does the first however many lines, tail does the last however many lines. We can run these together. So cat topic 11.log, pipe that to head -3 or -3, so the first 3 lines. There we go. And now if we further notice again, we don't have to specify the file name because the input is coming to head over standard input, not through file access. And then if we further pipe that to tail and say -1, we get only and precisely the third line in that file. So that's a way that you can access only one line out of a file. Pretty cool, right? Sorted list of all unique file extensions in the current directory. So this is quite an extensive one, but let's take a look at it. So you can see we've got all kinds of these different file extensions here, right? So list, reverse, cut D. You don't have to memorize this. On the period character, F1. Don't know what that flag means. Reverse again. Sort, unique, C. Unique count. So there you go. Here is an alphabetized list of all of the file extensions in this directory, and a count and a count of the number of occurrences of it. So there are 10 PNG files, 6 PNG backup files, 1 .txt file, etc., etc., etc. So that's cool. So you can see, you can just keep piping this data through different commands. So let's break that down, eh? So this is what ls does. ls reverse. There we go. It reverses. See, it takes each line of output from each line of output for ls, and it literally reverses it. There you go. Cut D on period F1 mode, removes everything past the period, including the period. We then reverse it again. So now, there you go. Back to front. Sort them. Now they're in order. And now count unique. There you go. Very cool. So, when you do Lab 10, you're going to be asked to compose a bunch of these different types of operations. And most of them will have to do with using the find, grep, and sed commands, which we're going to get through, which we're going to go through today. But that is my recommended manner of sort of composing these commands, is to do them one command at a time, right? Take a look at the output that you're getting and make sure that the output you're getting looks good. It looks correct, right? Okay. Good. So, piping and loops. You can even combine piping with loops in order to loop over the output of different commands. Like, this is kind of like a for loop in Python. So, ls while echo, while read item do echo. Yup. Ood. Done. Yep. There you go. I wonder if you can one-line that. You can one-line that. Ha! That's cool. So, here's the thing, though. Sometimes we're in a situation where what we actually want to do, sometimes we want to convert between the standard input that a command is receiving and the actual arguments to that command, right? So up to now, everything we've been operating on, all of these commands expect something from standard input when a file name isn't specified. However, sometimes, like sometimes what you want to do is you want to operate over files themselves. So the thing that you're going to be passing around is a bunch of file names. In, you know, let's say you use a command to generate a list of files, like the find command. Then you can use commands on those individual files, but what you need to do is you need to redirect standard input to the arguments of those commands rather than just having them come in over standard input. And this is what the xargs command does. So the way that xargs works is you pipe something to xargs, you then have whatever flags you want, and then you have the full listing of the command that you want to operate. Xargs, by default, takes each line and turns it into an argument, right? And it turns it into an argument and runs this command once for each one of those arguments. So in a lot of ways, it's very similar to this while loop construction, right? So when we pipe standard output to a command, the entire output is directed to standard input regardless of separators, spaces, or new lines, etc. What if the command we want expects its input by argument rather than by standard input? The xargs command will repeat other commands, feeding them input gathered from standard input. So, in the above case, the output of ls, which is separated by whitespace, is broken up and fed into rm individually. This command, therefore, succeeds. So, I'm not going to do this in my good folders. Let's see here. No. Yeah, the stuff in labs I can just get rid of because it's done. So ls lists all of the things in the directory. If we pipe ls directly to rm, rm is missing operands, right? That's an incorrect use of rm. However, if we xargs it, this will take everything inside of ls and feed these things one by one into the next command, which in this case will be rm. So if we take a look at what the output of xargs is, you can see each one of these guys, every file in this directory, which has been listed using ls, each one of these, including the directories, is individual. So if we rm it, we've got some issues, but it works for a lot of things. You may notice something about if you're keen, you'll notice something about all of these files that were not deleted by rm, as opposed to the ones that were. This is the list before. This is the list afterwards. What's the difference? You can get a hint from here as well. That's right, folks. When spaces occur inside of file names, when they're listed, xargs is breaking on every piece of white space, including those that exist inside of our file names, right? So this is a file name, 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 at least with respect to xargs. So there are various things we can do about this that we'll get to a little later on. But this is primarily one of the reasons that in Unix it is considered bad form to include spaces inside of your file names. because it messes around with these things. You know, like in Unix, it's considered even worse form to include the / character in file names, because that's a directory separation character, right? The difference between Linux and Windows, though, is that Linux will still let you do it. If you want to create a file that has, this / that, in quotes, I think. There you go. Maybe? Nope. Okay. Maybe I escaped the character? Nope. Okay. It's possible. It is possible. I accidentally did it earlier this week. But, yes. It's possible to create file names that include the directory separator. So, gross. Anyway. So, xargs. Xargs is very important. Most of the programming puzzles that you will be presented with in Lab 10 will require you to use xargs. In the case of the above, output of ls, which is separated by whitespace, is broken up and fed into rm individually. The command therefore succeeds, at least where xargs was able to break things up along actual file names, right? The spaces interfered with that. We're gonna see how to deal with that a little later on. So, but you may say, ha! I want more control over this situation. Let's say we wanted to copy all of the files in a directory with the .txt extension into a directory named temp. We would use something like the following. Don't worry too much about find. We're going to have slides on that a little later on. Basically, it finds all of the files that match a glob pattern. Don't worry if you don't know what a glob pattern is. Again, we're going to talk about what glob patterns are. So, by default, xargs pipes in arguments at the end of the list of arguments of the command that it's encapsulating. So its default with xargs, the default place that it's going to be putting things is right here. Whatever the end of your whatever the end of the command is. This may or may not be what you want, right? With the cp command, for instance, what we would want is we would want to copy it from here to temp, right? This isn't at the end, so we need to do something to make it to make that work. And it turns out there's a flag for that. So if you include the I flag and then specify some name, this guy will be substituted for the argument that xargs extracts from standard input. So if you plop it down right here, then yeah. Let's just make that recursive. Let's also actually make a temp directory. And, well, I got to do this in a different folder, actually, so that, I'm going to absolutely destroy these directories by the time I'm finished. Right. Now let's try it. File name too long. Yeah. That makes sense. I'm just having to do the fix for things with spaces in them. There. Now, if we take a look inside of temp, come on. Yep, that's good. Xargs with the 0 option. Yep. Copy ix, copy x to temp. Okay, looks like it's done something. Yeah, there we go. So in the current directory, this is what we have. If we go into temp, this is what we have. You'll notice the only thing it's done is excluded any directory because we didn't include the recursive option, which is how you have to copy directories. So there you go. I hope you guys were paying attention through that, because that's like the process for debugging these things. Yes. So, all right. Are there any questions about that much? If not, we'll move on to globbing. Any questions? Two votes. Both no. Haha! Okay. So, so let's talk glob. Like, why is he talking about glob? Why is glob a term that I have to hear in my computer science class? Is that not a term I should be hearing in my life sciences or biology class? You know, if you add 3 globs of DNA to 2 globs of RNA protein synthesis. Anyway, so glob. I'm not sure what it stands for, to be honest with you, but you've been using glob patterns for quite some time, actually. Probably way longer than you've been taking this class. So a glob pattern gives us a way of representing file paths that match a pattern. We use special characters to represent multiple characters in various ways. So the most common way that you'll see a glob pattern represented is in the star.c, star.text, star.h. When you use that to mean all files of, the .c file extension, you are using a glob pattern. The thing about glob patterns, however, is that they are a more general, they're a much more general tool than they're commonly used for. Like the hands down, the most common use for glob patterns is to identify all elements, all files that have a certain file extension, right? However, this is not the only way that they can be used. if you include a question mark, that is a single character wildcard. The character is required to exist, but it can take on any it can take on any value. So, for example, if I were to go up a bit and say topic echo. Echo is a great way to test glob patterns. Echo topic question mark space star. You'll see that I get all of the file names, or all of the directories that have a single digit, right? If I use 2, I get only those that have double digits, right? Glob patterns. So that's very useful sometimes. The star character is something that you should, like, we will know about it already. Basically, that's 0 or more continuous question mark wildcards. So you can have any number of wildcards, including 0 wildcards, represented by that asterisk. This effectively replaces any number of characters, including no characters at all. So if we remove all .c files, the pattern requires that the pattern won't match anything that doesn't have dot and c as the terminating characters, but anything else is fine, right? You can also, and this is kind of interesting, choose between multiple specific strings, comma separated. So if, for example, I wanted to grab only topics 1, 2, 3, 4, and 5, I get only topics 1, 2, 3, 4, and 5. I hope you're paying attention to this, because I kind of expect you to do something very similar to that on the lab. So if you're having trouble with the lab, come back to this lecture, because these tools are all you need to do the lab. Plus a little bit of ancillary Googling about some of the extra flags on some of these things. But it will be obvious when that's the case. So, great green globs of greasy, grimy gopher guards. Ha! Brace expansion also supports using two-period syntax, which you sometimes see in languages like MATLAB M files, to be iterating through a series of options. So if we expand, for example, 1 to 9, you get all of those. Notice, however, that these are single character expansions. If I were to do 10, 11, well, okay, so it works for integers. You can also do negative numbers. There you go. So you can just generate sequences of numbers right there in the terminal, which is very cool. Notice that these are all space separated. That can be important. So it works a little bit differently if you do characters, though. If you're sticking to the same case, then that's all fine. Capital A to W, sure. However, if you start mixing these guys, you'll notice A, Z, Y, X is in reverse order. So you can reverse the ordering on this by putting the positive thing out front and the negative thing in the back. That'll give you a reverse order. But the other thing is we've got all of these busy characters in the middle. What the heck is going on? The astute student might ask. Well, I'm going to show you something that should explain everything. ASCII table. ASCII tables explain everything. ASCII tables explain everything. See? Look. Brace, 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 brace. All of those characters. Oh, look. Are those the exact same characters except for the backslash character, which gets printed as nothing because that's backslash character and therefore the escape character? Yes! So you can actually, when you're using just general characters and not things that are recognized to be integers, you're actually going through the characters as such. So bang all the way to tilde. Oh, I guess bang is a reserved character here. We'll try quote. Quote is probably also reserved. Yes, it is. Come on. Work with me here. Pound. Dollar sign? Said percent sign? Maybe it's just too long. But, yeah. How about 0? Oh, man. This is what the lectures are, by the way. Your professor playing with computers. Yeah. You sort of run into these issues where a lot of these characters are used. Like, they have specific meanings. So, you know, it is what it is. But yeah, so glob patterns. Is question mark only for numbers? No, actually it will do anything. So if I wanted to say echo A, B, gotta do it with one of the other ones that I was using before I got into this. Yes, there we go. If I wanted to do topic, it still matches, right? So, yeah. Oh, chat was disconnected there and successfully reconnected. Yeesh. So, oh my gosh, I gotta get moving on this. So, it's generally speaking a absolutely horrific idea to use with glob characters literally in file and directory names, but if you really, really have to, you can use the escape, the backslash to escape special characters used in glob. So if you want to literally name something, if you want to literally put a asterisk in the file name of something, which is a terrible idea, but if you want to do it, use the backslash character to escape it. There we go. So, cops and globbers. I had some fun with the puns in this slide deck. So, glob patterns will expand to a list of delimiter-separated path names. It searches the paths, finds everything that matches it, and then just plunks that in. So, this guy copies all files with a .txt extension to temp, right? But this doesn't copy the file .txt into all directories in the current directory. That's not what it does, right? If, let's say we had directory 1, 2, 3, 4, all the way up to X, right? The second command expands to file.txt, then directory 1, directory 2, all the way to directory R. This copies, so the way CP works is it copies everything into the last thing, right? So this is not going to copy this guy into, it's not going to copy this guy into all of these directories. It's going to copy everything here into the last one. So the way that you would do this is that you could it would be better to find all of the directories and then use find to get all the directories and then xargs it into CP so that you control how it executes. So, good. What a find! The find command allows us to locate files in our file system using glob patterns. Unlike CP and RM, find automatically recurses through directories. So, for example, find, let's go up a level, find star.txt. Starting in the current directory and using the name flag. Do I have to put this in quotes? Yeah, I have to put that in quotes. Sorry, I have to put that in single quotes. So, there we go. This is a list of all the .txt files that exist in this directory and all directories under this one. If I wanted to find, for example, all PDF files, here are all of the PDF files. You'll notice that there are some of these that are like, discontinued, so to speak. My folders are a little bit on the cluttered side, but that's okay, because it's more data to process. So, find starting directory, dash name, then a glob pattern. If, for example, I want to find all of the PDFs that have a capital F in their file name, there they are. Very powerful techniques. Very powerful techniques. If I wanted to do all PDF files that have a capital F followed by some, like any character, and then a lowercase n, that only matches 1. Right? Glob patterns. If you want to limit if you want to limit how deep the search process goes, you have a max depth flag, which you can set. That just limits how deep the thing's going to go down into directories, which is fine. And here are a few more options for you. The F flag tells find to target only files. The D flag tells it to target only directories. You can even use flags to invoke Boolean operations to perform multiple tests at once. So you can also do this with glob patterns, right? If you wanted to check both C and H files, you could just do it in curly braces. But, the one that's interesting is not. So you can grab all files that are not like PDFs or something like that. All files that are neither PDFs nor LaTeX source files. You can do all kinds of stuff like that. Very cool. Any questions before we move on to regular expressions? I'm actually kind of thinking I should jump ahead to documentation. Give me a thumbs up, eh? I think I should jump ahead to documentation, actually. Given the amount of time I've spent on things so far, I might need to... Documentation is today's lab, so that must be covered today. So, okay. Good. So, documentation. Let's talk documentation. Then we'll come back to regex. The greatest obstacle to discovery is not ignorance, it is the illusion of knowledge. So some languages, like Haskell, are somewhat self-documenting. C is not one of those languages. When we say self-documenting, what we mean is the language itself is easier to read, and people have a habit of choosing file names which are descriptive. So if you pick function names, not file names, file names too. If the function names are descriptive and the variable names are descriptive, it's not just like X, Y, and Z, then that is considered code self-documentation. When you read the code, you get a better idea of what the code means because the variables actually mean something. But self-documentation is completely inadequate for a language like C, which is sometimes kind of difficult to read. So, code can be documented either A, in the source code, which is useful for programmers, or B, in an external document, which is useful for all human beings, including programmers. A recent trend in code documentation is literate programming. That is, the source code is annotated in such a way that documentation can be generated from it automatically. So this is a really good idea to do. However, you won't do it unless you have a literate programming system that you've set up for yourself. So we're going to learn how to use doxygen. So, documentation do's and don'ts. Do, write for your audience. If that is other developers, which it will be most of the time, they are interested in the technical details of how the program runs because they might have to modify it. If you're writing it for a client, then you don't need the technical details, you need more of an interface level, right? Use clear variable and function names. This is known as self-documentation. You want to comment A, the tops of the files, B, functions, C, structs, D, type defs, and E, control structures. It's very, very useful when you make an if statement to check something. Just write in above that if statement, this is, checking this, that, or the other, right? Checking to make sure this is a character and not a string. Stuff like that. Boop. So, when you document, explain how and explain why. Here are some documentation don'ts. Don't explain what each line of code does. You can, documenting each line of code is cluttering, and it does, first of all, it takes a long time, and second, it doesn't contribute anything. Especially considering most of the time you'll be doing the second point, which is explaining how the language works. You, a developer, can assume anybody who's reading your comments is sufficiently adept with the programming language that they don't need it explained to them. That's just patronizing. Don't leave sarcastic comments. There are some fun examples of this on the internet if you Google around for them. We won't do that now. Do not be emotional in any way. It is not your purpose to take your emotions out on your fellow co-workers through the use of comments in code. It is better if you don't take your emotional problems out on your coworkers at all. You are a programmer. You are you should be attempting at all times to elevate yourself above the mere meat vessel in which you find in which your consciousness inhabits. You are the paragon of rationality. You should not have emotion. You should not be emotional. Every decision that you make with respect to programming should involve no emotion whatsoever. It should be strictly math, and that's how your comments should reflect that. Don't comment each line. Yes, that's I guess what that says as well. Don't write anything you wouldn't want anyone else to see, including your boss. Don't slag off your boss in the code comments. Good way to get fired. Unless you work at Valve. So this is just a quick overview of the types of documentation that exist. I'm not going to go through this in a huge amount of detail because we got to keep moving. But generally speaking, from projects starting to projects finishing, you'll have various different documents that are generated, not always by you, the programmer. You know, in a large company, this would be different departments coming up with different documents. But high-level requirements and design documents, that will typically be something that's shown to the customer, so it'll be written in language the customer will understand. Detailed requirements and design documents, that's like, okay, the customer wants this, this is our plan, right? Testing and QA, you'll want you'll want plans for testing, you'll want test documentation, right? The reason you do this is because subsequent programs can follow similar testing schemes to older programs, so you don't have to reinvent the wheel each time. That's one reason to do it. End-user documentation is usually, you usually want to have some end-user documentation. This is like installation guides, user manuals, system requirements, all this kind of stuff. System documentation, sure. And then, of course, a final report, which would be internal for your company. Doxygen! Doxygen is fantastic. Wouldn't it be convenient to be able to generate documentation directly from your source code? Enter Doxygen, a popular tool for document generation. It is available at https://www.doxygen.nl/index.html. The languages it supports are C, C++, Objective-C, C#, PHP, Java, Python, IDL, Fortran, VHDL, and D, to a certain extent. It can generate LaTeX, HTML, man pages, and many other things, including Word documents. So, let's just load up the not surprisingly, the documentation for Doxygen has been done in Doxygen. So this is roughly what it'll look like when you're finished with it, with the possible exception of this nice card table background. So this is roughly what Doxygen looks like. Again, you're going to have plenty of time to play with this in the lab. To use Doxygen, you must first, well, you have to first download it. But once you've downloaded it, you invoke doxygen/g. This generates a doxy file, which is a configuration file that has a large number of configurable options, even more than Dwarf Fortress. It is important that the project name field be set, and if your source code is strewn among several directories, that also needs to be configured. By default, it'll look for your source code in the same folder that you have invoked Doxygen from. Very often, you want to keep your source code in a different file, like a /src source file folder. So if it is in a source folder, you need to direct Doxygen to that source folder to generate your documentation. But again, you'll see all of this in the lab. Doxygen, yes, checks your working directory for source code files by default. To generate a document, you type doxygen doxy file. So you load the doxy file into Doxygen, and then it generates your documentation. To begin a so that's how you use Doxygen. Doxygen will be able to pick out a surprisingly robust amount of data from your source code files without you even having to leave a single comment. However, we're all about doing things thoroughly, so this is how you leave a doxy comment. It's basically, in C at least, if you open up a multi-line comment and provide 2 asterisks instead of just the 1, these asterisks here are just decorational. This designates this comment as a doxygen comment. Anything that's put inside of here is labeled to be included in the doxygen documentation. If you position these at the tops of functions, structs, typedefs, or files themselves, doxygen will recognize the position of the doxy comment within the file relative to the thing it's just above, and it will consider this doxygen comment to apply to the next thing in the file, which is generally how comments work. Doxygen also looks for commands to produce more informative documentation. Commands, generally speaking, start with the @ character, though some of them start with \, and @param documents function parameters. There's a bunch of them that we'll see in Lab 9. So when you open up Lab 9, you'll be expected to take some source code files and document them. So there you go. You will now know how to do that. Any questions? If not, I'm going back to regex. Whenever I learn a new skill, I concoct elaborate fantasy scenarios where it lets me save the day. Oh no, the killer must have followed her on vacation. But to find them, we have to search through 200 megabytes of emails looking for something formatted like an address. It's hopeless. Everybody stand back. I know regular expressions. We're going to learn how to be wizards today. Cool. So, regular expressions. They're kind of like glob patterns, but more general and more useful. And, yeah. So, glob patterns are wonderful for managing the file system, but they lack the expressive power to be used on larger targets, such as the files themselves. So, glob patterns are for file names. Regular expressions are for file contents. Enter the regular expression. This is going to be like kind of a rough intro to regular expressions, but you know, like what I'm trying to say is that regular expressions are a whole topic they're a whole topic in computer science. They're based on a model of computation called finite state automata, which if you have never heard of that before, I would recommend asking your professor in 1DM3, the algorithms course, because they would be able to help you out with that. We're not interested so much in pulling apart the sort of academic details of regular expressions. We are interested in actually using them on files, primarily. So, similarly to glob patterns, regular expressions allow us to write character patterns, which may then be used to test or search for large groups of characters within larger groups of characters, like files. There is an excellent online tool for testing and debugging large and small regex. It is regex 101. So, while I recommend normally that people use Python Tutor to debug their C and Python code, my opinion of this guy, regex 101, is that it's basically essential, especially for a beginner. If you're not using this, then I think that you should be. So if we put like a bunch of text in here, we insert our regular expression. The most simple regular expression is to just type a word, right? So concept matches this instance of the word concept. And this will give you all of the matches, right? So if you want to match like the vowel group EA, it finds all of the instances in this text which match that pattern. right? And you can, like, jump to them. This is extremely good. This is an extremely good tool. Like, good God Almighty, this is a good tool, okay? Use regex 101. If you don't, you're doing it wrong. I'll even go that far. So, how do you regex? Here are some syntactic tools. So, the vertical bar separates alternatives. So, A or B matches A or B. So, in this example, which is also taken from regex 101, I'm matching EX or IN or ID. You can see all instances of EX, IN, or ID have been matched. Okay? So, for example, in this guy, if I match EA or found, or let's do like all the articles, the, an, there you go. Of course, this is matching things inside of words as well. The way that you fix that is to use B. B means word break. So there you go. So that is all of the articles in this article. Wow. Jokes. Cool. Next. Round braces determine how a regex operator is bound. So, if you have things in braces, that means it's these three characters plus this or plus that, then plus these guys. So this guy matches only tomato and tomato. Okay? In this example, we have E followed by either SSE, XA, or NIM. And you can see that that's how things have been matched here. Okay? You guys with me so far? Give me a thumbs up. So now we're getting into things that look a bit more like glob patterns. A postfix plus means that you have to have one or more occurrences of the character or the character group indicated. So A, B plus C will match ABC, ABBC, ABBBC, etc., etc., etc. So in this regular expression, I'm matching Batman, or hey hey, goodbye, etc. And the way I've done that is I'm just matching the capital NA, then I've got at least one na, and then either Katamari Damacy, Batman, or hey hey goodbye. So one expression matches these three things. Very cool. So the important thing to note here, notice how this is in braces, right? So you can say you can match repeated groups by including the braces. Okay. Incidentally, if you want to actually match on parentheses themselves, you would use let me see here. Let me see. Where is it? Here is it. If you want to match braces themselves, you use the escape character. There you go. So you can see these guys, all three of these guys matched. Incidentally, I just gave away what the single character wildcard is. It's period. So if you want to match on actual periods, you have to escape the period character. But that's okay. Cool. Quantification 2. So plus means one or more occurrence. Asterisk means 0 or more occurrences. It's not a million miles off of what it means in a glob pattern. So x, y, star, z means x, z, x, y, z, x, y, y, z, x, y, 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 z, etc. So if we had banana, na star, that wouldn't match banana. It would match but not nana. Banana, na, 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 na. Banana, bandana, ham sandwich. You can see what it matches here. Cool. Wildcards. The wildcard character matches any character. So A.B matches A.C or AAC, ABC, ACC, ADC, AEC, etc., etc., etc. So, in this particular example, we've got E with 2 wildcards and then another E, or M space wildcard. And you can see that that's how it's being matched. Cool. So, any questions about that? Hopefully this doesn't look like... It looks simple now, but constructing these things, these things get complicated, right? So when you're designing regular expressions, use this guy, okay? Even if it's simple, because it's good practice for when it gets hard. Incidentally, you can repeat the single character wildcard. So, yeah, it matches everything but new lines. So this star or period star matches entire paragraphs or possibly the entire thing. So there you go. Boop. Oh my gosh, I hate it when I hit that. Oh, okay, so this is fine. So we now know something about regex. Let's find some applications. While find searches the names of files, grep searches the contents of files. So with grep, you invoke grep with whatever flags you want. You have a pattern. The pattern is a regular expression. And you give it the files you want to match that regular expression over. As with many commands, we can specify multiple files to be searched using glob patterns, and we can search directories recursively using the R flag. If no file is specified, grep searches your working directory. The E flag allows us to use extended regular expressions, which have some additional operators, which is kind of cool. We're going to go through those now, but let me demonstrate. So, slides. Let's find every instance of the word pointer. Grep R pointer. And, yeah. There you go. This is everywhere in every file that the word pointer is used. And, you know, obviously we can use the full capability of regular expressions here. So if we, for example, wanted to find every 5-letter word that starts with the letter I, in lower or uppercase. We could do I ... 5-letter word, or I ... Well, that's not true. I know that can't be the case. Let me see here. Oh, I get it. These guys are wrong. Maybe? Oh. Wait. I'm probably messing up the syntax. Oh, and then has a space afterwards. Sure. Anyway, you can see why you want to test these things. So, anyway. Oh, maybe if I use the E flag. Ah, that's close. That's better. There we go. Some of this is, like, not quite what you want, but yeah, there we go. So, use the capital E flag whenever you're doing any of this. So, the bar character works as expected. It was the best/worst of times. Matches either it was the best of times or it was the worst of times. You can also use square braces to alternate many characters. So if you want to select anything that's a lowercase letter, you can just do that. Matches any lowercase letter. Notice how our regex is delimited by single quote characters. That's important. So regex delimited by single quote characters. Very, very important. Period is still the single character wildcard. So super .ario matches super ario, super barrio, super cario, etc. Question mark is a postfix operator indicating an item is optional. So A question mark B question mark C matches C, AC, BC, and ABC. Star postfix operator indicating 0 or more of one item, so the same as regular regex. Plus still has the same meaning as well. As shown in the above example, round braces are still used for grouping. So there you go. Although we have the square braces to alternate larger groups of single characters, some common ones have been collected up for us. So we've got alphanumerics, alphabetics, spaces and tabs, all white space, numerics, lowercase alphabetics, and uppercase alphabetics. So there you go. This, so lower, and then upper, one upper followed by more than one lower, repeated multiple times, and then a blank, matches anything written in camel case. There you go. Piping grep commands together finds the union. So the result. So basically, you're performing grep over grep output, right? So you have to match the pattern twice. If you put the hat character as the first thing, the first character inside of square braces, that's a not. That inverts the selection. So in this case, we're matching everything but ordinary, right? Yes. caret at the beginning of a pattern requires the pattern to start at the beginning of the line. So if you're using this as the first character in the pattern, that means this starts at the beginning of the line. And if you use $, this means you're testing that this is at the end of the line. So it's actually kind of cool because you can test to see if there are any blank lines by just doing that, and you can see all of the blank lines that exist in all of these things, which is kind of cool. So we've talked about grep for a little while. Let's talk about sed. Sed is a command, stands for stream editor. It is actually an extreme, it's got an extremely large number of things it can do. We're going to use it for just a couple of different things. But, just using sed would be a whole lecture in and by itself, at least. So we're going to learn how to do some simple things with sed. Any good programmer knows that find and replace is the most valuable tool any text editor can have. If you haven't been using find and replace, time to start learning it. Sed, or stream editor, allows us to perform find and replace operations with all the power of bash and regular expressions. It's pretty rare to find a text editor that allows you to perform find and replace over regular expressions. Pretty rare. So, the general syntax is you invoke sed, you use the I, stands for insert, whatever other flags you want, then you have the pattern, and then you have the input file. The pattern, in our case, the one that we're going to be using most, is s/some regex, then a replacement string /g. The regex expression tells sed where to perform the substitutions. The string is the replacement text. So this will trace through every file that it's given, and anywhere it matches the regex, it will delete that which matched and replace it with the string. So you can delete stuff outright if you provide a blank replacement string. For example, the following operation replaces any of the above specified trees with the string tree. So, oak, spruce, larch, maple, ash gets replaced with tree, and in the file.txt. Very useful under sedation. Of course, we can combine this with the power of find to be able to perform crazy operations, like perform find and replace operations over every file in the file system that we have permissions for, perform find and replace over all the files in a directory and subdirectories of a particular file type, perform find and replace on a file we don't know the exact location of. So, if we find everything in home directory that is a C file and replace stdio.h in angle braces with it in regular quotes, that will trace through every C file on our entire system and replace all of the angle braces with quotes in one line. Imagine, just think for a moment how long that would take you if you had to do it by hand. Right? Well, I mean, if you're using the Pascal server and this is the only class you've ever taken, that's one thing. You know where all the files are. Imagine, however, that you are a developer working at a company and it's not your account and you don't know where all the files are. You can perform code refactoring over entire operating systems using this. I cannot overstate how powerful this tool is. So, whoop, jeez. All right. So, Problems in space. So, in practice, searching commands can take a long time to execute since they are often sifting through gigabytes of data. So if you think about if you think about grep, right? If I were to do something extremely silly, like go to my root directory and grep recursively the word import. See how long this is taking? Absolutely ridiculous. Right? Of course, I'm trying to find lots of things all at once, but I'm just going to cancel that. So, one way that you can narrow the task, you can narrow the focus of grep is by using find to match some glob patterns first. Maybe you don't want to change every instance of this to that. Maybe you only want to change that in .c files. Find will reject files based on their file type so that they don't have to be grep searched, which saves you a hell of a lot of time. Yes, if we have to perform a grep search with a large search area, but we know something about the files we need to search, like they are all being C files, we can pipe the result of find into grep to substantially increase the speed of the search. One problem we'll run into, however, is that xargs considers both new line and space characters to be argument separators. This can be a real problem if our directory names contain spaces. We've already alluded to this problem. So this is a grep search for the term actually space. Fortunately, a number of commands, including find, allow us to set a special delimiter which xargs can be configured to look for. So if we apply the print 0 flag to find, print 0, and we apply the 0 command to xargs, basically whenever find finds something, it'll place a null character at the end of the thing it's found, and you can configure xargs to look for those null characters using the 0 flag. If you do that, then basically it won't split things on spaces anymore, which means that it'll keep your file names whole even if they contain spaces. However, you did it to yourself because you put spaces in your file name, and I include myself when I say that. So, yeah, oh my goodness, I guess I didn't have to jump ahead to do documentation because we're actually done a little bit early. Are there any questions? What's today's lab like? Yeah, I'll answer that if there's no questions about the material that we've covered today. Yeah, okay, got a thumbs up. Okay, I wonder how many people are still watching. Oof. Hey, we peaked at like 14 today. That's not bad. So, yeah, not to step on Nish's toes too much, but Lab 9. Lab 9 from outer space. So, essentially, there's a couple of small parts. there's a Markdown tutorial. Just go to the webpage, do the tutorial. It'll teach you how to write files in Markdown style. Markdown is an increasingly popular way to do like readmes and stuff. Next, I expect you to learn how to do latex formulas. I also expect you to look up the tags. So, you know, Lab 9 and Lab 10 kind of, they expect you to do a little bit of like reading on the internet to find out how to use the particular thing you're trying to do. Generally speaking, you shouldn't need to travel any further than Stack Overflow. But just write these so the thing about latex style formulas is that they're also used in Markdown. So this is the way that you would produce formulas inside of your documentation, generally speaking. It's also a good intro to LaTeX. LaTeX is the standard document generation system for computer science. So if you intend to do any graduate work in computer science, you absolutely need to know LaTeX. So you might as well learn some now. Also, it's not too difficult. We set up a makefile to generate... we set up a makefile to handle the both the compilation of the files I'm giving you and the generation of the documentation as well. Since it's all just command line invocations, there's no reason we couldn't put that in a makefile. So makefiles. That also involves configuring your doxy file. Then there's a bit for setting up GitHub pages. Or at least coming very close to setting up GitHub pages. Basically, I'm showing you how to get it to not only use doxygen through GitHub Actions, but you actually can acquire any piece of software that you want through GitHub Actions if you do certain things. So we're going to go through that, including CPP check. Then there's the actual documentation bit. So you're expected to go into these files, write stuff about them in doxygen format. You're going to be marked on how good your doxygen, doxygen generated documentation looks. So you have to use the tags correctly. So please write your comments and then check to make sure they're good. So documenting structs, documenting functions, and then README integration. So you're going to write some README stuff as well. So yeah, that's I don't think it's terribly difficult. This one's very paint by numbers. It's the it's Lab 10 that's going to be essentially a bunch of... Lab 10 is basically a bunch of puzzles related to the regex and pipes and filters stuff that we just covered. So, Lab 9, not too bad. Lab 10, probably bad. Not bad, but, you know, from a student perspective, it's not going to be the easiest of the labs we've done so far. So, yeah. Cool. Well, if there are no more questions, then I think I'm going to log off here. Yep. Anyway, good luck on the lab. If you're thinking with respect to Lab 9, it's not meant for you to think too deeply about it, so if you're thinking very deeply about it, you're probably thinking too much. But that can't be said for Lab 10. So, take her easy, folks. Good luck on it. And, yeah. Take her easy.